Hello, and welcome to the video on synthesis for aromatics using EAS reactions. That's electrophilic aromatic substitution. For synthesis, it matters what reactions you know so that you'll be able to complete the puzzles, as they say. So I just wanted to make sure it was clear which reactions you'll need for this video. So the first thing is you'll need the 7 reactions that are EAS reactions that we've been talking about in class. So these are in your class notes numbered 1 through 7. For example, halogenation, nitration, sulfonation, etc. So those reactions. The other reactions we'll need are some supporting reactions that are from the supplemental reading. These are to change different functional groups back and forth. So these are numbered 8 through 12 on the supplemental in your supplemental reading folder. They are, for example, oxidation of an alkane, converting an amine to an amide, etc. So you'll want to make sure that you review those reactions first and have them handy so that we can put them together in the following synthesis problems. So as you recall from last time, we said that different groups on an aromatic ring will have different directing effects. Those are things that could be either ortho-para or meta-directing, and that will have an effect on their product substitution. So the product that you get matters based on the order that you add the groups. So that's going to be really important. So if you're not really clear on that or you don't feel good about the directing groups yet, make sure that you practice that first. So you want to go back to the activity that's on the substitution patterns, the directing effects, and make sure that you can do all those questions. All right, so if you haven't done that yet, stop the video, go back to that. But if you have, please proceed. So as usual, I like to have a general strategy on how to approach different types of problems. So let's talk about what that strategy is going to be for aromatics. The first thing I'm going to do, if it's an aromatic type of synthesis, is I'm going to identify the substitution pattern. So usually there's going to be more than one group on the benzene ring, and so we want to identify the relationship between those groups, which could be ortho, meta, or para. The next thing that we would want to do is consider the type of directing effects found for the current functional groups. So whatever functional groups are already on there, see if they're meta directors or ortho-para directors. And then maybe that will be all you need and you can just put them together in the right order. If they don't already have the correct directing effects, we can fix that by using some of the transformation reactions, but we'll have to see as we go. So the next step is going to be to list all the reactions that will make the functional groups that are shown. So all the ones that you can use to put those functional groups on an aromatic in this case. This is something you always do for synthesis. You want to list them either in your mind or on a piece of paper to make sure you know what pieces you have, and then you can put them together. In some cases, you'll be able to use either protecting groups or masking groups, but it depends on the functional groups available. That doesn't work for all of them. So we'll talk about that as we go. The last thing you do once you get all the possible pieces you could have is you're going to determine the order of the reactions. Because as we said, if you change the order, sometimes that'll change the substitution pattern. So you have to make sure you go in the right order. So now that we've sort of got the idea for the strategy, let's actually see it in action and work on some problems. So as you can see in this first example, we're going to try to do a synthesis problem where we start with benzene, and then we're going to go to the product shown on the right. So as we said, the first thing we want to do in our strategy is to identify if the substitution is ortho, meta, or para. So which do you think it is? Right, so in this case, this would be a meta substitution. Because as you recall, it goes ortho would be 1 away, meta is 2 away, and then para is where they're across from each other, so it's like a 1-4. Okay, so the next thing we want to do is figure out what directing effect the things that are on there have, right? So if we look first, let's start at the bromine. So the bromine, what kind of director is that? Right, it's an ortho-para director, okay? And then up here we have an alkane, so what kind of director is that? That's also ortho-para, right? So are we going to be able to use these to make this? Not directly, right? We're going to have to use some tricks. So just keep that in mind. All right, so our next step is we want to figure out what reactions we can use to make the things that we see, the functional groups that we see on the aromatics. So what are some reactions we can use to put a bromine on an aromatic? Pause the video and think about what reaction that would be. Is this what you got? Right, so we're going to use the halogenation, right, and we're going to use the bromine version, so it looks like this. Okay, so then the next thing is we can put on an alkyl group. How do we do that? Pause the video and think about that. All right, so what'd you get for that? Right, it's a Friedel-Crafts, right? So we can use a Friedel-Crafts alkylation to do that. So then, are there any other ways we know how to make either of these functional groups? So do we know another way to put a bromine on an aromatic? Not right now, right? We just don't know anything like that. All right, is there another way we know how to make an alkane? Yes, right? There is another way you know how to do that. So we can do a Clemmensen reduction on something with a carbonyl. So if we put a carbonyl, say here, then we could turn that into an alkane. So that's another option that we have. All right, so now we want to see if we can put some of these pieces together to get the product that we're shown. So before we start looking at it, let's go ahead and label these reaction A, B, and C, and that way we can talk about them more easily. So remember, the one important thing we're going to have to remember is the directing effects. So we already said we can't just put the bromine on and move forward and make that product. We can't just put the carbon on and just move on and make that product, because both of those are orthopara directors. You're not going to get the right product. So do we see in our new reaction something that would be a meta director, since that's the one we're looking for? So I actually do see one. It's in reaction C. Do you see it? Right, it's going to be this ketone here. So if we use that, we can make the alkane that we want, but we also will have a meta director. So in order for that to work, we're going to have to show how we're going to make that carbonyl, obviously. So let's go ahead and write that reaction as well. Right, so it's just going to be a Friedel-Crafts acylation, so it should look like this. So now let's think about which of the reactions we're going to want to do in order. So we already know we're not going to use B, so we can go ahead and cross that one off. We're not going to use it at all. So do we want to put on the bromine first, or do we want to put on the ketone first? Right, so we want to put on the ketone first, so that's going to be D, because that's going to be our meta director. So we need it to already be on there before we try to add the bromine. So first we're going to do D. Then next step is we can go ahead and add the bromine so that it can do the meta directing it's supposed to do, so that would be A. And then the last thing we'll do is take off the carbonyl and we'll do step C, and that's going to give us the final product. Does that make sense? Now, just before we move on, let's make sure we're clear. If we put on D first and then we do C and then we do A, what would happen? What would be our product? Right, so if we do that, we're going to be having a meta director but turning it into an orthopara director, so we would still get the orthopara product. So that's not what we want to do. So we have to go in this other order that we said. Okay, so let's just draw those reactions out now. That's all we have to do. So if I'm going to go from the first one, I'll draw benzene. So it looks like this, right? We'll have to know that structure. And then we said we're going to do reaction D first, so we'll add that. And that's going to add 2 carbons, right? We put the carbonyl right by the benzene ring. And then once we get that, we got our meta director on, we're going to do A. So we just draw that. It's going to make the bromine, so we'll put the bromine in the meta position. And then the last thing we're going to do is just draw this to get to the product, and that's all you got to do. All right, so hopefully that makes sense. It's a slightly different process than you might always use for the other types of synthesis, because you do like strictly backwards approach. In this one, you have to be a little bit more careful about the order because of the directing effect. So it's a little bit different. But the nice thing about the aromatic reactions is you don't have to remember every single reaction we've learned, because a lot of the organic one reactions aren't relevant. It's going to be just the things that are in this little section. So that's kind of nice. All right, so hopefully that makes sense. There's lots of reactions you can do this way with functional group transformations. So you want to make sure you have all those reactions that can change the functional groups, and that'll be helpful when you're looking at that type of problem. And with that, that's a good stopping place. So we are going to stop for now, and then we'll start back up with another video that shows you a few more strategies for how to get ortho and how to get para specifically. So make sure you check those out. Thank you. Bye.